Super. Well, it's my pleasure to introduce Tobey Curtis, also with NOAA, and I think sort of picking up on a different thread here on what Scott was just talking about. So without further ado,
Audio good? I'll speak up, everyone can hear me okay? Thanks very much. For the invitation to be here, it's been really exciting and eye-opening so far, so I'm really excited to be here. As Scott mentioned, I'm sort of picking up where Scott Rogerson left off, kind of the next step for data coming from Argos. Talking about the telemetry network, specifically the U.S. Animal Telemetry Network, which is really Marine Animal Telemetry Network, or NOAA. We're mainly in the marine realm. Hopefully the terrestrial avian folks will find it of interest as well. I'd like to acknowledge my co-authors, Meg McKinsey, who is our ATN data coordinator, and Matt Biddle and Gabrielle Canonico, who are in the USIU's office in the Marine Life program. So, marine animal movement. Anyone recognize this quote by any chance? I just found this one the other day. I'm really excited about it. To me, if life boils down to one thing, it's movement. To live is to keep moving. It sounds like a very wise quote. I was thinking Thoreau or David Attenborough. No, it's another very talented observer of human nature. So, but appropriate quote from Mr. Seinfeld. Marine animal movement, just like everybody else, it's the satellite telemetry in particular is rapidly advancing. You can sort of see the pink trend lines there. The increase in the number of studies per year over time is increasing. This is from a paper by Nigel Hussey et al. in 2015. And you can see locations. It's a global reach. There's obviously clusters in some of the more well-resourced parts of the world, but global coverage and a growing use of satellite tracking technology in the marine. We're a marine mammal variety of species. You can see most in the bottom plot, most of the deployments so far are with marine mammals and sea turtles, but also a growing number of sharks and other fish as platforms continue to get smaller. We're certainly hoping to expand applications to a lot more fish species and other things. So we're using satellite tags, Argos mainly, for geographic movements. That's the big focus of a lot of our work, is these kind of large-scale geographic movements. This is from Barbara Block et al. And the Tagging Pacific Pelagics program, so a specific focus on multiple species. So you see how they sort of are kind of sharing the Pacific habitat, which is amazing. So the geographic scale of movement is important, but the ocean, like the air, it's a three-dimensional environment, so we're also using satellite tags to gain insights into vertical behavior of marine animals. Very important element for fisheries management. When we're talking about overlap of fisheries, different types of fishing gear, our ability to detect them in surveys and research studies. And so you can kind of see here, this is a recent paper by Sandy and Basic et al. With just sharks, kind of showing synthesizing shark depth distributions. You can see most of the species that have been studied so far are generally in the upper 200 meters of water column. The deepest dive, I believe, is kind of to the right there, is a whale shark down over 1,700 meters, and that's about the maximum detection range for satellite tags before they reach a crush depth. The photo is of a basking shark. It's a photo I got during my PhD work on basking sharks. There's an interesting factoid I was talking about with Lacey yesterday. Basking sharks are actually the first marine fish to carry an Argos platform. That paper was published in 1984. So when that was sort of like first, dipping our toe into the potential for satellite tagging of large marine fishes. And at that time the tags were huge. They're like a mag light. And things are a bit smaller, but they're still kind of big, most things. So the framework I wanted to kind of talk about is, next steps from the data collection. Talk about end users. This is a framework put forward by Hayes et al. It's a really great article in Trends in Ecology and Evolution about sort of connecting data to conservation policy management. And the general framework is, getting your tracking data, getting it into data repositories, which is one of the roles that ATN kind of brings to the table. Coalescing that data, provisioning scientific and technical advice, so producing data products, but also giving technical advice to the people that need to hear the advice. You really need to get in the room with managers. It's a big part of this. Organization, and then ultimately we're leading to management measures in the marine realm. That's things like marine protected areas, fishery management areas, shipping restrictions, trade restrictions, helping recover endangered species or overfished fisheries. And so there's a lot of, I work in NOAA fisheries, as I mentioned yesterday, I'm on a detail in ATN. I'm a telemetry user, but I'm also a fisheries manager. And so I really try to build that connection from telemetry data collection in the field, bring it to the table for fisheries managers, and try to implement, get the data that can really change policy. And there's a lot of applications, a lot of potential there that is still sort of unrealized, and hoping that we can continue to build those bridges. So talking about ATN, this is still a relatively young program. It's only been around for about 5 years. It sort of went through a big change just 4 or 5 years ago. And this vision is still very much a work in progress. The vision for ATN was sort of acknowledging that the existing marine animal telemetry capabilities were valuable, but kind of an incomplete mosaic of independently operating efforts. I think this probably sounds familiar to a lot of you. So unifying and sustaining them would significantly improve the collective cost effectiveness and increase the value to the agencies whose missions require data, marine animal movement and behavior. So very easily translated to the terrestrial realm. So an alliance of collaborating partners enables science by maximizing collaboration, access to telemetry data, integrating telemetry instruments with existing observing systems. This is things like putting receivers on data buoys or oceanographic ships and things like that. Improving data standards and sharing capability, cyber infrastructure. It's a common challenge, I think, for all of us, getting data standards, and the more we can have standards and share that template across the community, the more interoperability there can be. So I'm bringing continuity and permanence to the national baseline telemetry system. So we want to provide sort of a kind of a central clearinghouse that can serve the broad marine animal telemetry community and provide some standards and data delivery to the people that need it. So this really led to 3 call them pillars of ATN. We want to build alliances and collaborations that's within government and outside of government with partners. A lot of telemetry research in the US is funded by the government, so we want to collaborate as much as we can. We want to support baseline animal telemetry observations. This is through ATN, this has mainly been through supporting acoustic telemetry networks. We have regional acoustic nodes, all using the ocean tracking network sort of platform. They're based at Dalhousie University. It's supported by the Canadian government. And so they have a very great grassroots approach to acoustic telemetry data sharing and interoperability that benefits the entire acoustic telemetry community. So we try to do what we can to support that system. And then providing the telemetry data management and delivery. There's a lot of scientists and users in the agencies, like myself. We collect the data, not necessarily great data scientists or data managers. ATN provides a place that you can sort of just plug in your data and they'll take care of it. They'll archive it. If it needs to be open access, they can DOI it. They can put it on Data One or some of the other NCEI data repositories. Make it publicly available and meet sort of public access requirements across government. This is an infographic I made recently. Something got lost in translation there. So the satellite tag in the middle should have a seal attention. So mainly we're talking about Argos here and satellite tagging, so I'm just going to throw out the acoustic piece for the moment, but just pretend there's a seal on that satellite tag in the middle. So Argos systems, and this is just to demonstrate, at least within NOAA, this is how I'm trying to advertise ATN and what it offers, and what one tag on one animal can what management applications like an end user or manager can use. And it can be used in fisheries for stock assessment, bycatch reduction, essential fish habitat, ocean observation, like ocean profiling. I'll have another slide later where we're actually using marine animals, sharks, and mammals to be oceanographers. They're giving us temperature, depth, and salinity profiles that can then be used by the National Weather Service in ocean models and hurricane prediction. So that you can get, even though it's an ecological observation, you're tracking animal movement, that same data can get plugged into weather prediction, which I think is pretty cool. Climate adaptation along the same lines, we're monitoring shifting distributions of all kinds of marine species, especially here in the Northeast, warming faster here in the ocean, more than over 90% of the planet. A lot of things are on the move and has ramifications for coastal communities, fishing communities, and everything. Offshore and renewable energy, offshore wind is a big deal here in the Northeast, and telemetry is a big part of the sort of monitoring plans for a lot of species, and trying to study the impacts of offshore wind construction and implementation on marine habitats and species. And obviously conservation is a biggie, protected species under the Endangered Species Act, sanctuaries and other types of marine protected areas, and then ecosystem-based management. So one tag can check all those boxes across multiple NOAA line offices, but also other places across the government. And even getting NOAA to acknowledge this, the power of this has been a challenge, it's an ongoing challenge. But then getting the academic community to use the same resource and then make their data available to decision makers. We're trying to prevent that happening as well. Kind of at the center of ATN is the Data Assembly Center. Megan Kinsey, who I mentioned, manages this. It's a community resource. We receive data from multiple sources, and we promote the data availability and sharing among community partners. This helps maximize access to telemetry data, enhances and expands electronic tag data products. The DAC actually has a number of sort of checkboxes where they have analytical tools where it'll analyze your data, it'll filter your satellite positions, do some QC kinds of things. And then enables the permanent archiving at CEI or Data One. And this is all automated at this point. If you submit your data in the right format and the right template to ATN, all this stuff is taken care of for you. And this is done because we put a lot of time into developing these data pipelines. So this is an Argos satellite data pipeline. Data comes in at the top. Everything in the red box is ATN. All those functions take place through the cyber infrastructure we've already built. And then at the bottom, you have your data repositories or products or end users. The access there. Similar for archival tags, the pop-up satellite archival tags. We have similar pipelines for those. So the portal is sort of public facing. You can go and search what's in the portal. Not all the data that is in ATN is available in the portal. It's sort of an extra step. This is sort of the unembargoed, publicly available data. Right now there's 129 projects from 65 PIs, 50 different organizations, over 70 marine species now, over 4,000 tags, and almost 11 million locations. And they're sort of clustered in different places. And this is because some rangers are more open with their data than others, or the project is further along, so it's been published and unembargoed. But just this is sort of an example of what's available in the portal. On the right, if your tag is vertical data, you can see some of the vertical profiles. And then, of course, the geographic positions and the map interface as well. This gets back to the animal-borne profiles. This is a really powerful thing. ATN sits within the Integrated Ocean Informing System Office at NOAA. So I'm a biologist sitting in a room full of physical oceanographers trying to explain the importance of biology and animal movement to people that are focused on very important things, climate modeling and hurricane prediction and things like that. But we're trying to show that animal telemetry tools, satellite tags, can plug into this pipeline and be very useful. And so ATN has built the only pipeline that I'm aware of that automates certain tag types or certain tag models available from a couple different manufacturers that produce these temperature depth conductivity profiles. And if you plug them into ATN can rearrange them, get them in the right format, and they go to the National Data Buoy Center, and then get fed into to GTS, which is where all the World Meteorological Association data goes. Oceanographers around the world can grab that and plug it into their ocean models, and whether that's for climate or hurricane prediction or storm prediction kind of stuff, you're getting at like surface ocean heat content, and most of that data currently comes from oceanographic surveys, satellite products, Argo floats, and gliders and things like that. If we had a fleet of animals with these tags out there, it would be way more cost effective than spending hundreds of thousands of dollars on gliders. If you have 100 sharks swimming around randomly providing 100 profiles a day, you're going to kind of blow up the ability to collect this data. You can't control where they go, obviously, but if you have enough of them out there, they're going to provide really good coverage. So really exciting new direction for the technology and for ATN to service that deliverable. And then this is a cross-cutting thing I think we've all touched on too, the need to link telemetry data with other sort of traditional biodiversity data sets. We have the Marine Biodiversity Observation Network in Bond, and I use sensors, so we want to be linking telemetry and other sort of presence-absence data, traditional biodiversity data, eDNA, passive acoustics, as well as matching that to environmental data from other IOS services. So this is an ongoing conversation. We're working hard right now on sort of integrating ATN into the larger marine life program of IUs, and just acknowledging that this is about marine life, this is about, and telemetry data, animal movement data is just one type of biodiversity observation. And so we're trying to find ways to marry those data types. So more on that hopefully in the next few years. So to sort of meet some of the objectives of this workshop, I want to think a little bit about what tag users need in the marine realm. And so I came up with this short list. This isn't based on anything other than my personal experience for the most part. But I think it's shared widely across the marine tagger community. We really need some stability in the satellite systems and data delivery. It sounds like Scott has got that covered well with Argos, and it's a very exciting time to be putting tags on marine animals. Expanded coverage and data transmission bandwidth. Sounds like we're getting that covered. And then on the platform side, always aiming for smaller platforms with longer life, faster geolocation, better geolocation, more sensors. Right now, most tags, archival tags, are just sort of depth and temperature. But if we get conductivity, oxygen, pH, and other sensors, we can really expand the ability for animals to monitor their environments for us. And then data management services, like ATN, of course, they're getting cheaper. The cost of satellite telemetry is still very high. And you can see that in just where the tags are going out. They're going out in the US, and then parts of Australia, New Zealand, South Africa, Europe. And so we need to, this is like an environmental justice issue to me. We really need to make access to the tags, just lower the cost of entry. The cheapest satellite tag out there right now is $1,000. And that's just a pop-up location only kind of Argos transmitter. Put it on for 100 days, 200 days, the tag pops off, you get the location, a little bit of temperature data. That's $1,000, and that's a lot of money for entry into the satellite tag. The more advanced pop-up satellite tags are $4,000 or $5,000 per animal. So sounds like we're moving in that direction, which is exciting. Again, our end users that we need to keep in mind are fisheries and marine mammal, sea turtle management agencies, communities, federal and state agencies, tribal communities, private industry, the energy sector, tourism, educational institutions, and the general public. These, being in NOAA, we have very applied science kind of approach. We have very critical data needs, and we need telemetry data for very specific management objectives. And so, I encourage everyone to think about, applying, think about avenues and pipelines to make the data you're collecting applied to conservation. There's a real need for it. So end users, what do we need? Access to data products, repositories, and portals. Hopefully ATN is serving that role. It's still a work in progress, but I think we're moving in the right direction. So specifically, we need distribution, migration, population, connectivity, data, information on essential or critical habitats, biodiversity hotspots, multi-species products, like we talked about yesterday, and exposure to anthropogenic impacts, shipping, offshore energy, fisheries, habitat degradation. There's lots of species and habitat threats out there, and telemetry data, animal tracking data is one of the best ways to get that information. So we need sound scientific and technical advice. Again, this is kind of getting back to the HAZE framework, the HAZE et al. Framework for getting your data not just published, because as a manager, it's way too much to read. We don't publish, or we don't read everything that's in the literature. You need to get in the room with people and share your results and really get it out there to the managers. So get that technical advice to the managers. And we need more data on more species in more places. And again, that gets to the cost of entry into satellite tagging and the size of the platforms. The smaller they get, the more species we can tag. And that's hopefully a long-term goal for the community. What's measured is managed. where we have animal movement data, it is very much used in management. If we don't have the data, we're kind of stuck with more traditional observation data products, and there's limits to all biases, whether it's net surveys or presence data or citizen science, there's inherent biases and limitations to those. Telemetry really helps fill those gaps. And so hopefully, when you have those measurements, it can make it to management. Cool transition, I didn't know was there. So this is, you saw this yesterday from Kara's talk. This is just sort of, again, ATN is trying to fill this role of connecting data to end users. And we're on the right path. There's a lot of data in there. We're trying to get a lot more. And to wrap it up, so animal telemetry technology is rapidly advancing. It's a very exciting time to be an animal movement scientist. The need for data management and delivery support is advancing commensurately. So think about strategic ways we can find interoperability and standardization to make that part of it easier for all of us. And then just keep the needs of end users in mind as your technologies and products and results come online. There's a lot of need. We're in the ethical scene, and we need to get this data in a very applied way very quickly. So thank you. That's all I have. And we've got time for questions.